bond between carbon-carbon is single. If there is a compound and if it is saturated, then the bond between carbon-carbon should be single. Then it is an alkane. Alk, basically, this alk represents the number of carbon, and ane that represents nature of bond. That means basically single. If it is written alkane, that means the bond between carbon is single. So here I am going to make a chart, number of C atoms, that means basically carbon atoms. Then what will be its name, and then the formula, and then a structure. We will also talk about the structure. So if we already know the formula, general formula of alkane, that is CnH2n plus 2. So if we have a saturated hydrocarbon in which carbon is 1, then it means meth. If the number of carbon is 1, then meth. And since we are only talking about alkane, that means single bond. So the name will be methane. If number of carbon is 2, that means eth. And since it is singly bonded, that means ethane. If the number of carbon is 3, that means prop. And single bond, that means propane. If number of carbon is 4, that means but, and since it is in singly bonded, that means butane. So basically 1, that means number of carbon 1 meth, 2 eth, 3 prop, 4 but, and ane because they are all singly bonded with other carbon. That's why it is methane, ethane, propane, butane. The most important point is here. You are going to write the formula of ethane, methane, propane, butane. So as you can see, the number of carbon, whatever is the number of carbon, the number of hydrogen will be double plus 2. So it will be CH4. In the same way, it will be C2H6. In the same way, it will be C3H8. Double of the carbon plus 2, 3 to the 6 plus 2, that will be 8. And then C4H10. Now come to this, what will be the structure? So the structure of methane is basically very simple like this. Now what is the structure of ethane? We have 2 carbons, so just you are going to write CC, and since it is alkane, singly bonded, so write single bond between carbon, and then divide the hydrogen in equal part. That means 3 hydrogen to this carbon and 3 hydrogen to this carbon. Now come to the structure of this propane. It has 3 carbon, and since they are alkane, so they all are singly bonded. Now fill the bond of terminal carbon, that means left carbon and right carbon. As you know that carbon can make maximum of 4 bonds, so 3 hydrogen will be given to each terminal carbon, left carbon as well as right carbon. And we had a total of 8 hydrogen. So 6 hydrogen is already distributed. Now we are left with 2 hydrogen. So 2 hydrogen will go to this carbon. Now you can see all the valency or bond of carbon is satisfied. Carbon makes 4 bonds in order to satisfy itself, in order to complete its octet. So you can see in one bond there are 2 electrons, and each carbon is making 4 bonds. That means 8 electrons. Octet, completed octet. Now come to this C4H10. So you are going to write 4 carbon in a straight line. 4 carbon in a straight line, and since it is alkane, so you are going to write the single bond in all of this carbon bond. Now divide this hydrogen terminal to the terminal carbon. Give hydrogen to the terminal. So terminal carbon will take 3 electrons, left carbon as well as right carbon. Now we have since we just distributed 6 hydrogen. Now we have 4 electrons. So we 4 hydrogen. So we are going to give 2 hydrogen to this and 2 hydrogen to this carbon. So it's very easy. So this is the structure of butane. This is the structure of, I'm going to write, this is the structure of basically propane. This is the structure of ethane. This is the structure of methane. Please do write. Let me know when you are done with this. Are you done with this? Martin, Hamna, Afra. Afra, are you a new student?
Yes, sir.
Today is your first class, right?
Yeah.
Have you studied this chapter, carbon and its compound?
Done, sir.
Done. Everyone done with this? Afra, have you ever studied this chapter before? Martin and Hamna, please do respond. Afra, are you done with this?
Yes, sir.
No. So Afra, see how I just wrote the name of the formula of the compound. First of all, you have to remember if there is only one carbon, that means meth. If there is two carbon, that means eth, 3 carbon prop, 4 carbon but, 5 carbon pent, hex, hep, then oct, then non, then dec. So this is the general formula of alkane. If you have one carbon, then the number of hydrogen will be basically double the number of carbon plus 2. So what will be the number of hydrogen? Double the number of carbon. One carbon is there. So what is the double? 2 plus 2? That will be 4. Now come to this. If you have 2 carbon, the number of hydrogen will be double. 2 to the 4 plus 2, that is 6. Number of carbon is 3. So what will be the number of hydrogen? 3 to the 6 plus 2, 8. Number of carbon is 4. So the number of hydrogen 4 to the 8 plus 2, that is 10. Is that clear, everyone? Now come to, if you have 5 carbon, then we say pent. And since it is singly bonded, that means pentane. So what will be the formula? Number of carbon is 5. Can you tell me the number of hydrogen? Afra, Arshia, anyone of you? Martin, what you just said?
Hydrogen should be 12.
12, yes, it will be 12. Now, if you have 6 carbon, that means hex, and since it is singly bonded, so aim. 7 carbon, that means hep, and since singly bonded, aim. 8 carbon, that means oct, and singly bonded, octane. Now, please do write the formula, chemical formula of all these and the structures also. And if you have any doubt, please ask. Arshia, let me know when you are done with this.
Done, sir.
Very good. Afra, have you written the formula of all this hexane, heptane, octane? Martin,
Yes, sir.
are you done with this?
Till date,
The chemical formula of hexane.
I'm at 6 now, 7 now.
Okay, can you tell me this?
C6H14.
Very good. Then C7, H16.
Yeah.
Then C8, H18. Very good. Arshia, have you written the structure of this or this?
Yes, sir.
So it's very simple. What you need to do is write C, 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 C. How many C are there? 5. And
5.
put single bond between them. Then 3 hydrogen to the terminal carbon, left carbon as well as right carbon. Left carbon as well as right carbon. 6 hydrogen are given. Now we have 6 hydrogen left. So 3 carbons here left and 6 hydrogen. So give 2 carbon to each carbon. 2 hydrogen to each carbon, sorry. So this is the structure of our pentane. In the same way, you are going to draw the structure of all this and let me know when you are done with this. Arshia, you are done with all this. Abdullah,
Yes, sir.
you just joined.
Yes, sir.
Very good. Please do let me know when you are done with this, everyone. Are you done with this? No one is responding at all.
Yes,
Martin,
sir, I did.
Your answer, your answer.
okay. See the structure of hexane. You are going to write 6 carbon singly bonded and 3 hydrogen to the terminal and 2 hydrogen to the each carbon here. You are going to write hydrogen on. Afra, are you getting it or you have any doubt? Can I change the slide?
Yes, sir.
Martin, Abdullah and Afra and Hamna, please do
Good
respond.
answer. Good answer, done.
Yes, what you just said, Martin, can I change?
Done, sir. Done, done.
Okay. I'm going to write the structure of this also. 7 carbon are there. And you are going to give 3 hydrogen to the terminal carbons, left carbon as well as right carbon. So 6 carbons are divided, 6 hydrogen are distributed. Now we are left with 10 hydrogen. So giving 2 hydrogen to each carbon. Okay, I'm going to change the slide. Now come to the next. That is basically 9 carbon. That means non, and since singly bonded, non-N. 10 carbon. That means dec, and singly bonded. That's why decane. What will be the chemical formula? It's very simple. 9 carbon. So the number of hydrogen will be 20. Double the number of carbon plus 2. 10 carbon, C10, and the number of hydrogen will be double plus 2. So you can write the structure easily. Please do write it. Please let me know when you are done with this too also.
Done, sir.
Very good. Now see, this is very easy. There are concepts like if you have CH4, that is basically known as methane. This CH4 is methane. But if you are going to eliminate one hydrogen from this methane, it will be CH3, and one of the valency of carbon will be free. So it will be known as methyl. And this is basically alkane, and what we call it generally alkyl. If you have C2H6, that is ethane, or we can write basically CH3CH3. And if you are going to eliminate one hydrogen or remove one hydrogen from here, it will be either C2H5, one valency will be free, or either you can write CH2CH3. So this carbon is satisfied, but this carbon is not satisfied, the valency is free. So ethane will be converted into ethyl. In the same way, propane, if you are going to remove one hydrogen from propane, that will be converted into propyl. In the same way, butane can be converted into butyl, pentane can be converted into pentyl according to the situation or the compound. Is that clear?
Yes, sir.
Please do that. Please let me know when you are done with this. Can I change the slide?
No, sir, I'm doing.
Okay, please do write it. Abdullah, Martin, are you done with this now?
Yes, sir.
Now see, can you tell me how many sigma bond present in propane? I already explained the concept behind sigma bond and pi bond. There are two types of bonds, sigma and pi. Single bond is sigma, single bond is sigma bond. And if there is double bond, that means one sigma, one pi. And if it is triple bond, that means one sigma and two pi. Please do this question and let me know. It's very easy, Ashia and everyone. Martin, can you do this?
Yes, sir.
Hello, sir. I had some net problems, so I had to leave.
Okay, please do this question, Ashia.
8, right?
Okay, sir.
Martin, are you done with this? How many sigma bonds present in propane? So first you are going to write the formula of this. Prop, that means 3 carbon, and the number of hydrogen will be 8. Now you are going to draw the structure of this. 3 carbon is there. All are singly bonded because N, that means alkane. And you are going to divide hydrogen in an equal part to terminal carbon. And now you can see only we have 2 hydrogen left.
So there will be 10.
No, not 6. Now see, this is single
10.
sigma bond. I will check it. Sigma bond, 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 sigma and sigma. Now just going to check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the very good 10 sigma bonds in propane. Is that clear? Martin, Arshia, very good.
Yes, sir.
Okay, I'm going to give you another question of the same type. How many sigma bonds present in
8 bonds, right? Propane, right?
yes 10 sigma bonds, 10 sigma bonds present in propane. Now you are going to
How
calculate
10, sir? How 10?
what you just said. Martin, can you repeat it again?
10 sigma bonds, right?
Are you asking how 10 sigma bonds, right?
Yes, sir.
Okay, see, I just explained, just focus here, please. So you are going to write the structure of propane first. So if I'm going to write the structure, so do you have any problem in this structure?
No, sir.
Now, what I told you for sigma and pi bond in the previous classes, when we had single bond, double bond, and triple bond. Can you look at the structure? All are singly bonded. All are singly bonded. Single bond are there. Not no double bond, no triple bond. Martin, please do respond. Single bond, that means single line. Double bond, that means this is. Triple bond, that means this is triple bond. Martin, are you there?
Yes, sir. Yes, sir.
So all are sigma bond, all are single bond. That means sigma bond 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why it's 10 sigma bond in propane. Is that clear?
Yes, sir.
Okay. Please do the write the number of sigma bond in decane. So first you are going to write the structure of decane and count the number of sigma bond.
Sir, I can't read. What's the question? How many?
How many sigma bonds present in decane? Can you see the screen, Arshia?
Yes, it was blurred because of my net.
Okay. Please do it. How many sigma bonds present in decane? Afra, do you have any doubt in this sigma bond present in propane? Afra, please do respond. Did anyone calculate the number of sigma bond in decane? Martin,
Yes, sir.
did you write the structure of decane first? What does the chemical formula of decane? Dec means number of carbon 10. Since it is N, we are going to use the general formula of alkane, that is CnH2n plus 2. Whatever is the number of carbon, the number of hydrogen will be double plus 2, that means 22, H22. Now say it's very easy. We have 10 carbon, all are singly bonded. All are singly bonded.
41, right?
So I'll just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Now what you need to do, just give 3 hydrogen to the terminal carbons, left carbon as well as right carbon. 6 carbon is used. Now we have 16 carbon, sorry, 16 hydrogen. 6 hydrogen is used. So 2 hydrogen to each carbon, and you will get your structural formula. You will get your structural formula. You can count, it is 14 and then 2, 16 hydrogen. Now this is the structure of decane, and now you need to write the number of sigma bond, and all single bond are sigma bonds, and all the you can see all are single bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Very good, Martin. So there will be 31 sigma bonds present in decane. Is that clear, everyone? Arshia?
Yes, sir.
Okay. So this is basically a structural formula. You can say this is a structural formula. This is a structural formula. Now we are gonna study bond line formula. Bond line formula. How we are gonna write bond line formula? It's very tough. If you have given a large molecule to write the structure of that organic compound. So we use bond line structural formula. Bond line formula, which is very easy. Bond line structural formula. Bond line structural formula, and this is basically complete structural formula. We call it complete structural formula. That means basically CSF, and this is bond line structural formula. This is BSF, and BSF is very easy to understand. I'm going to write a point which you need to take care. The starting point, then terminal point, that is where it ends, terminal points, and vertex, this all represents carbon. This all represents carbon. And in bond line structural formula BSF, we don't need to show hydrogen. So what we need to do is only write the except hydrogen and carbon. We have to show other elements except hydrogen and carbon. Now see, there are 10 carbons. So if I'm going to write BSF of this, it's very easy. This is the first carbon. This is the second carbon. This is the third carbon. This is the fourth carbon. This is the fifth, sixth, seventh, eighth, ninth, and then 10. Now where hydrogen goes, it's understood that hydrogen is there. So you can write 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can see the starting point is carbon, the vertex is carbon. This represents carbon. Vertex and the starting points as well as the end point represents carbon. And this line, single line, represents it is all singly bonded. If you have a structure like this, That means the bond between this carbon and this carbon is double. The bond between this carbon and this carbon is double, and in the same way hydrogen manages itself. So basically there are 3 hydrogen because this carbon making single bond, that means there are 3 hydrogen. This carbon making 2 bond left or right, so there are 2 hydrogen. So first write it, then I will explain BSF in more specific ways. Everyone done with this? Please do let me know. Martin, are you done with this?
Yes, sir.
Okay. So I was explaining basically bond line structural formula. It's very easy to understand. I will start from very basic. Bond line structural formula. So see, it's very easy. If you have C2H6, so its complete structural formula will be like this. Like this. And if you want to show it in bond line structural formula, it just need to be like this, because the bond between carbon carbon is single. That means there is a carbon and there is a carbon, and you can see there is a carbon and there is a carbon, and all are hydrogen. All others are hydrogen. Like this. You don't need to show the hydrogen and carbon. You just need to draw a line, and this single line represents the bond between carbon carbon is single. Now another point, C3H8. So the structural formula of C3H8 that we have already done like this. You can see like this. Now, if you want to draw the bond line structural formula, this is the carbon, the second carbon, and the third carbon. And all hydrogen are understood that there is 2 hydrogen, there is 3 hydrogen, and there is 3 hydrogen. In the same way, C4H8. That means basically 4 carbon is there, and there is like this. Now you can see how many carbons are there. 4 carbons. That means 1, 2, 3, 4. And all hydrogen are understood that on the terminal carbon there are 3 hydrogen, and in between the carbons there are 2 hydrogen. Please do write it. Martin, are you done with this?
Yes, sir.
Okay. Do you have any doubt in this?
No, sir.
Okay, please write the structural formula. This is for hormone basically. Please do the one. Write the structural formula first that we just wrote in the above examples, and then write the BSF bond line structural formula for C5H3. Please do everyone, and if you have any doubt, please ask. Everyone done with this one? See, the structure of this is very easy that we have already written. C, 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 and then C. And 3 hydrogen to each terminal carbon. And 2 hydrogen in between these terminal carbons. Now, if you want to write the bond line structural formula, 5 carbon is there. This is the first, second, third, fourth, and then fifth. This is the BSF bond line structural formula for pentane. This is basically our pentane. So you are going to do this from homework and this also, and then C8H18 also. The BSF, that is bond line structural formula, as well as complete structural form.
Okay, sir.
So this is it for today. I will see you in the next class.
Thank you, sir.
Thank you.